Okay, my dear students, welcome back. So, today we are going to find the inverse Laplace transform. And we are going to focus on convolution. Inverse Laplace transform using convolution. Because there are other techniques also to find the inverse Laplace transform. So specifically in this video, we will focus on how we find the inverse Laplace transform using the convolution. Okay. So to start with, we will write the definition of convolution first. So if I have two functions ft and gt, and we are finding the convolution of these two functions, which I am representing by star. How this is defined? This is defined as fu g t minus u integral with respect to u over the limits 0 t. This is how you define convolution of two functions f and g. And because we are talking about the inverse Laplace transform, so we will use our property that L inverse of Fs multiplied by Gs this is equal to L inverse of Fs L inverse of Gs, and this multiplication which we have on the left side, this will get converted to convolution on the right side. This is the property which we are going to use today. Fs and Gs, they are actually the Laplace transform of the functions ft and gt respectively. Fs denotes the Laplace transform of ft and Gs denotes the Laplace transform of the function gt. Okay. So let us take a question and let us apply whatever we have discussed so far. So question is, find the inverse Laplace transform of, let us say, 2 over s minus 3 s plus 4 using convolution. This is our question. Find the inverse Laplace transform of this expression using convolution. So the question asks us to find the Laplace inverse transform of 2 over s minus 3 s plus 4. Now, to use this property, let us try to write this as a multiplication first. So this we can write it as L inverse of, let us say, 2 over s minus 3 multiplied by 1 over s plus 4. No problem. And now let us apply this property. So when we distribute this L inverse, so L inverse with 2 over s minus 3, L inverse with 1 over s plus 4, and this multiplication will get converted to convolution. So we will get L inverse of 2 by s minus 3 convolution with L inverse of 1 over s plus 4. Basic property of Laplace transform and inverse Laplace transform is that if you have a constant, you can always keep it outside. So this gives me 2 times L inverse of 1 over s minus 3 convolution with L inverse of 1 over s plus 4. No problem. And using the basic formula, Laplace transform of e to the power minus at is equal to 1 over s plus a. Or you can say L inverse of 1 over s plus a will be equal to e to the power minus at, the most basic formula of Laplace transform. So using this formula, we get that 2 times L inverse of 1 over s minus 3, that will be e to the power 3t convolution L inverse of 1 over s plus 4, that will be e to the power minus 4t. Now let us use the definition of convolution now. So 2 times e to the power 3t. So when we use the definition of convolution, so this is my first function and this is my second function, right? So this is our, let us say, ft, and this is our gt. Okay, so when we use the definition of convolution, this will be integration fu. So what we will do in our ft, we will replace t by u, so that becomes t 2 e power 3 u multiplied by g t minus u. So wherever you have t, you will replace it by t minus u. So that will become e to the power minus 4 and t will be replaced by t minus u. Integrating with respect to du over the limits 0 t. Now this is a simple integration problem. Let us complete this. So this becomes integral 0 to t 2 e power 3u e power minus 4t e to the power 4u du. And this gives us integral 0 to t 2 times e to the power minus 4t and e power 3u and e power 4u will combine, so that will become e power 7u du. u. Now, if you observe, we are integrating with respect to u. So this constant 2 and this term e power minus 4t, both of them we can keep outside the integration. So we can write it as 2 outside, e power minus 4t outside, integral 0 to t e to the power 7 u du. And this gives me 2 e power minus 4t. Integration of e power 7u will be e power 7u divided by 7 over the limits 0 to t. And finally, we will put the limits, and one more thing we can do, that this 7 also we can shift it outside the bracket. So that will become 2 by 7 e power minus 4t. And now we will put the limits t and 0 in e power 7u. So this gives us e to the power 7t minus, when we put 0, it will give us e to the power 0, right? So final answer is 2 by 7 e to the power minus 4t multiplied by e power 7t minus 1. So this is the inverse Laplace transform of the function which was given in the question. So this is how we find the inverse Laplace transform using convolution. I hope the explanation was clear. That's all for this video, and we will meet very soon in the next video where we will discuss some other topic. Take care, all of you. Goodbye.